Okay, so in the next couple of problems, we're going to find the difference quotient. The first example, f of x equal mx plus b. The difference quotient is f of x plus h minus f of x all over h. So f of x plus h means replace x with x plus h. M times x plus h plus b minus f of x means minus mx plus b. You're subtracting the whole thing, so make sure there's parentheses around that, and then all over h. Okay? When I distribute m, I get mx plus mh plus b minus m minus b over h. Mx minus mx, those are gone. B minus b, those are gone. And that leaves me with mh over h, which is equal to m. So the slope of this line is m. The difference quotient is a way to measure a point to another point. So how do you do that? Well, you look at m, right? If m is 1/4, you know you're going up 1 and over to the right 4. If m is -3, you're going up 3 and to the left 1. So whatever m is, that's how you get from one point to the next. Now that's okay with a line, okay? But what if you don't have a line? What if you got like f of x equal 1 over x plus 3? Okay, well, the difference quotient, f of x plus h, is 1 over x plus h plus 3 minus f of x all over h. I'm going to go ahead and get a common denominator here. X plus h minus x plus h plus 3 all over x plus h times x plus 3 all over h or 1. Okay? So let's see here. When I distribute the numerator, the negative sign, x minus x, those are gone. 3 minus 3, those are gone. And that's going to leave me with negative h divided by x plus h plus 3 times x plus 3 all over h over 1. Now the h over 1, I'm going to flip that. So I'm multiplying by 1 over h. And that's going to stick h in the denominator. Okay? So I'm left with negative h over h, which is going to cancel, divided by x plus h plus 3 times x plus 3. When I cancel those h's, that leaves me with negative 1 divided by x plus h plus 3 times x plus 3. Okay? Now, that's a way to remember the general form of how to get from one point to the next on a curve that is not a line. Okay? You're using a line to get from one point to the next, but you don't have a line given. Okay? You're creating a line, though, for an x value and an h value. H is some increment away from x. Okay? So if you're 3 increments away from x, h is 3. And if x is negative 1, negative 1 to 3 means that that's what you'd be getting. Okay? So let's find the domain, and more on that in shortly here. Let's find the domain of each function. As an example, g of x equals 2x divided by x squared minus 9. Okay, well, I know I can't divide by 0, so in the denominator, I'd want to set x equal to 0, or the expression equal to 0, and solve. X squared minus 9 equals 0. means that x equals plus or minus 3. Okay, and that's what I don't want. Set of all x such that x is not equal to 3 or x is not equal to negative 3. The next example, h of x equals 2x divided by x squared plus 9, means that the denominator is really the only thing I care about there, and x squared plus 9 will never be a negative. Will also never be 0. When I square any number, I'll never have a negative. And when I add 9, I'll never have a negative still, and I'll never have 0. So all real numbers are okay there for h. K of x equals 3x squared minus x plus 7 divided by x squared plus 2x minus 3. Okay, I care about the denominator, whether that's going to be 0 or not. So if I set x squared plus 2x minus 3 equal to 0, then I get x minus 3 times x plus 1. X minus 3 times x plus 1. Well, that means that x is equal to negative 3 and x is equal to 1. Okay? The set of all x, such that x is not equal to negative 3 and x is not equal to 1 is what I want. If I have another example, f of x equals the square root of 4 minus 3x. 4 minus 3x cannot be 0 or it has to be 0 or a positive. So if I solve this inequality, 4 greater than or equal to 3x divided by 3, 4/3 is greater than or equal to x. Okay, and that's going to be okay to have. Anything that is less than or equal to 4/3 is going to be okay. Okay, anything bigger than 4/3, we don't want that because that's going to create an overall negative number underneath the square root sign. As an example, suppose that g of x is equal to the cubed root of 4 minus 3x. Okay, the cubed root of negative 8 is negative 2. Negative 2 times negative 2 times negative 2 gives me negative 8. The cubed root of negative 27 is negative 3. Negative 3 times negative 3 times negative 3 gives me negative 27. So the domain of g would be all real numbers, since I can have the cubed root of a positive or a negative or 0, and that's going to be okay. For example, suppose that h of t is equal to the square root of t squared plus 1. The domain is all real numbers. Okay, now of course I don't want a negative underneath this square root sign. The square root of a negative is not a real number. So t squared plus 1 means that t squared is greater than negative 1. Well, that's always going to be true, right? T squared is always going to be greater than negative 1. Because if I square any number, I always end up getting a non-negative. Okay, so I'm always going to have something that's greater than or equal to negative 1. As another example, suppose that we have the square root of 3x plus 12 divided by x minus 5. Okay, 3x plus 12 greater than or equal to 0, subtract 12 and divide by 3, means that x is greater than or equal to negative 4. Also, I don't want x to be 5 because of denominator being 0. So anything that's greater than or equal to negative 4 is going to be okay to have, just don't use 5. The set of all x such that x is greater than or equal to negative 4 and x is not equal to 5 is the answer. Another example, suppose that f of x is equal to 2x minus 1, the absolute value of that. I can let x be anything I want. If I end up getting an absolute value of a negative, I know that's going to be a positive number. And so there's only two things that go along with looking for a domain at this point. That's division by zero. There is no division here. And then square roots. You can't have the square root of a negative. Well, I don't have any root going on. Okay, so the domain of f is all real numbers. Another example, express the area of a circle as a function of its radius. Find the domain. Okay, a of r equals pi r squared. A function of the radius, well, the radius would have to be some positive number. I can't have a radius of, that's negative, that doesn't make any sense. And a radius of 0 gives me just a point. So the radius has to be some positive number. Okay. Combining functions, function operations. Functions are like numbers in that they can be added, subtracted, multiplied, or divided. So for example, suppose that we have f of x equals the square root of 1 minus x, and g of x equals 4x cubed. F of x plus g of x is the square root of 1 minus x plus 4x cubed, and that's a brand new function that I've got there. Okay. Let f and g be functions. F plus g of x means I've got f of x plus g of x. We call it the sum function. F minus g of x is given by f of x minus g of x. We call it the difference function. Number 3, f times g of x is given by f of x times g of x. We call it the product function. And f divided by g of x is f of x divided by g of x. G of x can't be 0. And we call that the quotient function. The domains of f plus g, f minus g, f times g, and f divided by g include all the x values common to both the domain of f and domain of g. In the case of the domain of the quotient function, also include x values for which g of x is not equal to 0. Okay, so as an example, suppose that f of x is given by the square root of 2 minus x and g of x is the square root of x plus 5. If I want to compute the sum function, f plus g of x, that's represented by f of x plus g of x, and I would just simply add these two functions together. The square root of 2 minus x plus the square root of x plus 5 would be my answer. Now, the domain of f is the set of all x such that x is less than 2, and the domain of g is the set of all x such that x is greater than or equal to negative 5. Okay, when I overlap those two sets, it looks like anything between negative 5 and 2, including negative 5 and including 2, are going to be okay to use. 1, for example, is in this set. So f plus g of 1 means I've got 2 minus 1 is 1, the square root of 1 is 1, plus the square root of 6. 1 plus the square root of 6. Okay, and that'd be just an output that I've got from a... all right, so here's my last page. F minus g of x is represented by f of x minus g of x, which is the square root of 2 minus x minus the square root of x plus 5. That's all I can do. The domain of f minus g is the same set as it was for the domain of f plus g, which is the set of all x such that x is between negative 5 and 2, including those numbers. And how I get that is the same thing. Set 2 minus x to be greater than or equal to 0, and x plus 5 to be greater than or equal to 0. F minus g of 2, Okay, so 2 minus 2 is 0, minus root 7. Minus root 7 then is my answer. I've just selected 2 out of random. F times g of x is represented by f of x times g of x. F of x is the square root of 2 minus x. G of x is the square root of x plus 5. Okay, and here I can simplify. I can take the square root of 2 minus x times x plus 5. If I square that out, negative x times x is negative x squared. Negative x plus 5 is negative 5x, plus 2x is negative 3x. 2 times 5 is plus 10. So the square root of x squared minus 3x plus 10 is what I get there. The domain of f times g is the set of all x such that x is between negative 5 and 2, including those numbers. And f times g of negative 2, let's see here. I get the square root of 4, which is 2, times square root of 3. 2 times root 3, there's my answer. And I just made that up out of nowhere. F divided by g of x is the same as f of x divided by g of x. The square root of 2 minus x divided by the square root of x plus 5. I'm going to go ahead and rationalize the denominator. The square root of 2 minus x times the square root of x plus 5. Let's see, I've already done that. That's the same as the square root of x, negative x squared minus 3x plus 10. Square root of x plus 5 times the square root of x plus 5 gives me x plus 5. So as far as the domain of f divided by g goes, it's going to be the same as before, but x can't be negative 5. Okay, so I want to make sure that I lose negative 5 in there. And that's going to be the only thing that I do different. F divided by g of 0 gives me root 10 divided by 5, which is the output. And all these numbers that I'm selecting are in the range of negative 5 to 2. Okay, something to keep in mind. And most of them including negative 5 and including 2. Okay, 0, negative 2, 2, okay. The homework is on page 68. Be sure to look at the problems there over the basics about functions.